Hi everyone. Today we are doing notes for Unit 3, Skill 1, and this is on identifying functions and relations. So a relation is a set of inputs and outputs represented by ordered pairs, tables, graphs, or maps. A function is a relation such that each input has exactly one output. So these are different ways that a relation and a function can be represented. We have a map where you see you have inputs and outputs and you're drawing each input to each output. You have a graph where you can see ordered pairs. You have a table where you have an x value and a y value. And then you have a list of ordered pairs. And if you notice, for each one of these, we have the same values. They each have 0 mapped with -2, 0 mapped with 1, etc. So number 1 says, is the relation above a function y or y not? So in this case, this one is not a function, and this is because the input of 0 has more than one output. We see that 0 has an output of -2 and of 1. And so I'll highlight these for you. You can see here 0 goes to -2 and to 1. We see here goes with -2 and 1. We see in the table we have 2 listing of 0, and same thing with our ordered pairs. Okay, we need to determine if the following relations are functions. So number 2 here, we see that x and y are both listed in our table. So I have 1 with -9, 2 with 6, 3 with 2, and 2 with 5. So in this case, we have 2 with 6 and 2 with 5, telling us this one is not a function. Let's look at number 3 here. Here I have -3 mapped to 2, -1 mapped to -5, 1 mapped with 6, 4 mapped with 2, 5 mapped with 0. In this case, each input has exactly one output, so yes, this one is a function. For number 4, if we look, we have 1, 2, 3, 4. We have 5, 6. We have 7, 5, and 9, 3. So in this case, each input has its own output. So yes, number 4 is also a function. I want you to try 5, 6, and 7, please, now. Okay, for 5, we can see, looking at this one, that 1 maps with A and with C. We also have 2 maps with A and B, 3 maps with A and C. So in those cases, we have many inputs that match to multiple outputs. So this one is not a function. For 6, we have 6, -2, -3, 6, 3, 1, and 1, -6. Each input has its own output, so yes, this one is a function. And for 7, we have -5, 1, -5, -4. We have -2, 3. We have 2, 1, and 2, -4. So this one also has multiple cases. Here we have at 2, 1, and 2, -4. Those both have the same input mapped to different outputs. So this one is not a function. The vertical line test. This is used to test if the graph of relation is a function or not. If every vertical line you can draw passes through the graph at most once, then the graph is a function. If there's a vertical line that passes through the graph more than once, then it is not a function. So it says we can use the vertical line test on problems 4 and number 7 to verify your answer. So if we look at number 4, we can draw a vertical line through any one of those 5 points. You can see here, I can draw vertical lines. And in each case, they only touch 1 point, so that one is a function. For 7, if I draw to the vertical line, I could draw it here at -5 or here at 2. And in both of those cases, we touch 2 points. So this one is not a function, as we had. All right, so now we have to determine if the following graphs are functions using the vertical line test. So number 9, in this case, no matter where we draw a vertical line on this parabola, we can see it is only going to touch once. So this one, yes, is a function. Number 10, we have a sideways parabola. So I can draw vertical lines on here, and you can see that it hits twice in multiple places. So this one is not a function. I would like you, please, to do 11 and 12. Okay, for 11, if we draw vertical lines, you can see multiple places. This will touch twice. So for 11, this is not a function. For 12, no matter where I draw my line, we can see that it's only going to hit once. So this one, yes, is a function. Function notation, and this is a review from Algebra 1. F of x represents the output of a function. X represents the input variable. F is the name of the function, not a variable. So here we have f of x equals 2x plus 1. F of 7 equals 2 times 7 plus 1, which gives you 14 plus 1 or 15. So when x equals 7 is plugged into f of x, the output is 15. So 7 comma 15 is one of the points on the graph of f of x. So it says use the functions shown below to answer our questions 13 through 20. So we have f of x is 3x plus 3, g of x is 2x squared minus 1, h of x is -3. We have j of x is -4, 2, 5, 7, 8, 8, and 11, 17. And k of x, we have -3, -2, -1, 3. We have 0, 1/2, 1, 5, 2, 3, and 2.5, -1. So for 13, it says f of -4. So we're looking at our function f here. So f of -4, if I plug this in, we have 3 times -4 plus 3, -12 plus 3, which is -9. Next, we have g of -3. So here's our function g. I would like you to try this one. Okay, so we have 2 times -3 squared minus 1. Well, -3 squared is +9. 2 times 9 minus 1. 18 minus 1 is 17. Our next one, we have k of 2. So our function k at 2, we're at this point here, 2, 3. So k of 2 is 3 is our output, or the y value. 16, we have j of 5. So for this one, I'm looking at function j, and I can see when I input 5, my output is 7. So this one is 7. For our next one, we have h of 7. Well, if I look at my function h of x is -3. That's going to be our horizontal line, so our output is always -3. So no matter what the input is for h, the output is -3. Next we have g of 0, so we're going back to this function g of x and plugging in 0, so we have 2 times 0 squared minus 1. So that gives you 0 minus 1, which is -1. All right, I would like you now to try 19, h of 2. Our function h of x, remember, is -3, so h of 2 is going to be -3. And last, I would like you to try 20, f of 2/3. So here's our function f. So we have 3 times 2/3 plus 3. Well, if I put this 3 over 1, those 3's cancel. We get 2 plus 3, which gives us 5. And that's the end of our notes for today.